Hello and welcome. So we will start the next assembly as we have finished the first two assemblies. The next assembly I am going to take up is machine-wise assembly, or what we call as bench assembly in your machine shop and workshop lab, where it is used to hold the workpieces for filing process and fitting process. Your fitting the fixing the workpiece onto that device uh, based on the thickness of the workpiece, and you are holding it tightly and doing your workshop activities, filing and fitting operations, cutting the workpiece. For that, this simple device is used. It is an assembly. We will mm, just see this arrangement. It has a body, and there is a screw fitted into it. Onto the screw, this movable jaw is it can be translated anywhere based on the thickness of your workpiece. These jaw grips will hold the material, your workpiece tightly, and then to do carry your operations, cutting operations, filing operations. You might have seen this in our workshop and machine shop laboratories, where these bench vises are fixed onto the tabletops. Uh, just a very simple model here. We will quickly go through these part drawings. Individual part details have been given here. This is taken from the book, again taken from the book K.R. Gopal Krishna, and, and you can see here there are nine individual components coming into this assembly. The number one is body of the vise made up of cast iron and movable jaw grips, screw rod, washer, nut, lock nut, and clamping plate. All this arrangement, we will individually create this models, and as we did for first two assemblies, and then methodology will be same, but based upon these drawings, the operation will little bit change. The concept of modeling remains same for here, as these are also machined parts. Now, okay, now I will quickly go to the solid edge, and before that I will create a folder. I will just make machine wise assembly. Okay, now I will create the first part. I will open a part file. Now this is body of vise, and it is made up of cast iron. Okay. File, save, summary, body of vise, and its document number is 1, and I will go to desktop. I will call it as 001. I will define the material here. It is cast iron. Okay, now we quickly go through the details of this body of vise. Here it is called in terms of balloon callout 1. It shows the three views of this part. This one is front view, and below this is a top view, and here he has cut this model at this location at the center, and that sectional view he has shown here. This is section AA. So this is a sectional view which you with get some more details inside this part. Uh, so at the first instance, we will go through this maximum size required for this material as a stock size. Here you see this maximum length. One length you got here 230 will be the length, and width, extreme width is 180 mm, and the total height is 85 mm. So this size of a block is required to create this part. Okay, so I will go to the solid screen, select the sketch, select XY plane. I will you can create it in any one of the planes you want. In top view I will just create a rectangle to make a block. So I will maintain this origin as my symmetry, and 230 is the length in x direction. 230 by 2 I will keep it, and I will restrict it to 230. And in this direction, that is y direction, width is there. He has given it as 180. I will 180 fit it. So 180 by 230 block I have created. Now I am going to add this 85 in other direction. So return from this sketcher mode. With the protrusion option, select the sketch, enter, and in distance command you put 85. Okay, now this is the raw material required, or minimum size that is required to create this model. Okay, now look at the drawing where the material is going to remove. The major material here, it is not there, here it is not there. You just uh, have this profile so that we can remove and retain this side flanges. Okay, select the top face of this block, and I will quickly extract the edges of these symmetric planes, and then look the geometry. This width is 100, so I will just I will extract these extreme edges also. Now I will offset it by 50 because one side I'm making this, and I will also extract this edge, extend this center line, and I will look, this width is 120 from the center, it is 60. So I will quickly offset this line, and then here it is 40, the width is 40. To draw this slope I need to have a circle over here, tangent to that I need to draw a slope, then I should get a corner here. This is 13 mm below this, from the edge it is 13 mm. So I will offset this single. Okay, I will offset this single edge by 13 mm, and the center is 40 mm apart from the center. From the center it is obviously 20 mm. From P. Okay, here I will draw this. Go to these IntelliSketch, all these icons required to trace the endpoints are active or not. You just have to check it. I have explained it in drafting session. Okay, here also they are so intersection point I am identifying here, intersection of these two lines, and the diameter will be 26, the radius is 13. Now I will draw this slope. I will make it a tangent. So you can see the tangent command beside the cursor here. I will just draw a tangent to this circle and extend that further so that it meets this outer edge. I will trim this. I got now this slope. Now you can make a mirror of this, and you can just trim these shape unnecessary construction lines, everything. Quickly you erase all these. Okay, I will use these envelopes to remove this material and retain this main between portion. For this I will go back and use the cutout option, select both these profiles, and my distance is 85. Now I got the shape over here, and then I will quickly mirror this on other side about this XZ plane. So your both side your material has been removed. Okay. Now this flange has a 23 mm thickness. We have to remove this material also from 85 to minus 23. We have to retain this 23, and the remaining thing we have to delete it. Again take this top view as your sketch plane. Okay, now no need of extracting these center lines. Just extract these edges and close this end point and end point. And this profile is enough for me to remove the material. Take cutout option, select this profile. Distance, in the distance you maintain total height is 85 minus 23. 23 you have to retain. So you got the material for the flange creation, and mirror this feature on other side about XZ plane. I will just mirror it. So now the flange shaping material is retained and remaining material is gone. Okay. Front view, equip it, and uh, look for the areas where major material is to be removed. Okay, in front view you see this area has to be removed by maintaining this step kind of thing. By seeing these details you can have this profile and remove it. Okay, so now I will make it in front view, and I will select XZ plane is the perpendicular plane for me, and I will quickly create a horizontal line. This is about 57 mm, which I saw from the drawing. Here it is 30 plus 27. This horizontal line is there, and this face is 40 plus 5, 45 away from this edge, this extreme edge. So I will have one more line here, and I will constrain this edge 45, and then see anything is there from this face to this face. There is a 5 mm gap and 25 mm away from it, from the top edge, and there is a step. So again you draw a line here, and this is constrain it to 25, and then offset it by 5 mm. Now you shape your profile by trimming it, by deleting the unnecessary files. So this is what we require to remove this portion of the material. Go back to the solid edge 3D environment, and same with the use of cutout, give the direction outside and use symmetry. I will use 100 because 100 mm is the width. So now you got the keep it in front view. So if everything is fine, you proceed. Now this middle portion, a lot of material has been removed here, but it is not the shape. Actually he has taken a cut section here. You can see here from the bottom width is 60 of 10 mm depth, and then it is gradually decreased to 52 this width, and from bottom it is 13 mm this height. Then this width is here shown here 40. This will be throughout. There is a uh, uh, cavity. So in this way we have to create. From bottom I can create the simple rectangles and take this depths. Okay, so quickly go to the model and select this plane, make it wireframe model. Now I will use, and this top view dimension remains same. From here this edge is 5 plus 15 20, and then from here it will be, obviously it is 45 from the extreme edge. So from extreme edge you maintain 45, and from here you maintain 20, and this first block will be 60 size. From the center I will give 30 each. Now go back to the model. Now this depth is how much? Removal is 10 mm, I think. This is 10 mm. Okay, now 10 mm step has been made with this required size. Now immediately hide this sketch. Now take the same bottom plane again, just extract these edges, and then extract this. The next rectangle is 52, so I will offset this by 26 on either side. So close this profile by trimming it and remove this. So now this rectangle goes up to how much? 13 mm. Okay, so um, give 13 mm. So you can see here the step is created inside, and now I use the same XY plane, this bottom XY plane here, uh, convert it into visualize into wireframe model. Now same edges you extract. Now it is 40 mm depth. You have to take out the whole material from here onwards. Okay, 40 means from the center 20. Okay, now you just use this depth. This is from bottom, it is 57 mm. So now you can see in shaded side, in wireframe you keep it, or in top view if you see uh, whether you got the required size or not, just by keeping this in different views. Okay, now what needs to be done here? There is a flange, there is a 20 mm thickness, another 3 mm we have to retain this portion, and then slightly we have to go deep by 3 mm again, okay, by maintaining this shape. So we have to create this shape. For this you read these details. There is a 13 mm diameter radius circle is there, and then this center will be 13 from outside edge. So I will use this flange top face as my sketch plane, and I will extend the center line here. I will offset it by 13 mm from the outside edge, and I will create 26 dia, that is radius is 13 only, and I'll quickly offset this to get the shape. Trim these lines and quickly extract these edges. So this area should go down by 3 mm, keeping this material 23 mm only. So I will use cutout, select this profile and give 3 mm depth. So you can see now the step has been formed here. Hide this sketch and mirror this entity or feature about ZX plane. Click on this smart icon, So same step has been created on other side. Okay, now immediately take this top face of this flange, and now you go to the details. This is inside this, there is a 8 radius, 8 mm radius circle is there, and I will select the same center of the same outer dia. 8 radius means 16 dia, and I will offset it by 8. Close this profile and trim this to required shape, and remove the inside material using this profile. This is 23 mm. So now you can see the material is removed. Mirror this feature about XZ plane. So now they both are looking similar. Here there is a flange provided here. A round flange is protrusion is there, and there is a followed by holes. So we will make this protrusion. Then after we will drill the holes. This is from the bottom 30 mm up the center position of the center, and the diameter is 32. I will create a profile circle. Diameter is 32 and center is located from the bottom 30. So I have to make a protrusion. I have to use cutout command. Using side step, you remove this material by 5 mm. So keep this in front view so that you can see this protrusion. And if you look at the model, there is another side also. This protrusion is there, 5 mm, 32, same location. I think, I guess from here also it is 30. So select this face as a sketching plane. Again 32 dia. And use cutout, side step, and 5 mm thickness. Okay, now look for other dress up features and holes. Measure hole diameters. First bigger dia holes to be drilled, then smaller dia, then chamfers and fillets, etc. Like that it goes. Now the hole here he has mentioned, you can see the diameter here, and this is 20 mm diameter with of a length of 45. I think from this up to this face is 40 plus 5, 45. So drill a hole, use the hole icon, select this end, and it is a simple hole, 12 dia hole. No, sorry, a 20 dia hole with you give finite extent. It will ask you hole depth 45, and just select and locate it at the center. give the direction. The hole is drilled here. On this end there is a hole of 12 dia of 20 mm length. So choose this face as the drilling face. How much? 12, and hole depth is 20. Fix it on the center, and now these holes are drilled. Now look at the other holes. Here on this face he has shown here. These are nothing but these holes only, front view. Two holes, diameter 5 and deep 13, and tap M6 deep 10. Okay, and there are M6 holes, M6 threaded holes are there. Threaded length is 10 and total hole depth is 13. Okay, and this location is given from this edge, it is 12.5, and from this center they are 60 mm apart. So we directly go to the hole option, select this face. Here you threaded hole with you take M6 only. When 5 is mentioned, but when it is threaded it will become 6 only, up to hole extent, finite extent. So 10 mm is the thread length, and hole depth he has mentioned is 13, and V bottom he has used here. So take this first, randomly you um, place your um, hole previews. Later on with smart dimension you can use constrain the position. This is 12.5 from this edge. I will edit this dimension and then fit it from this symmetric plane. I will center, I will fix this, and from here to center I will like this. Okay, go to return command. Once the holes are located, you can see the front view. In wireframe you can see this. Okay, and some oil holes are introduced here to make this screw rod will be inserting in this. It is a rotate, always rotating, so in order to maintain the smooth operational functioning of the screw rod, certain oil holes are introduced in this body. So we will create those. He has given 3 dia of countersunk. The location here is it is exactly at the center line, and from outer edge it is 20. Depth is 30 plus this is 10, 40, so 45, 46, approximately 47 you can give here. So go to this top face, select the top face. They are optional, but still if you want to do the model accurately you can create countersunk. The shank dia is given here. Obviously countersunk diameter will be 2 times of that. Use 6 and use 90 or 82. The depth you give 45 or 46, and from here you just keep your here in line with the symmetric plane, and from outer edge the dimension he has mentioned is 20. So select this and choose as 20. Keep it as a front view wireframe. Okay, just there is no material here, already I have drilled a hole. It will come and merge with this hole. Okay, and similar hole is here. Look at the drawing here. One more hole is there, 10 mm away from it. Same dimensions. This is 30. So 27, 28 you give. Then depth, it is enough. Mm, You can choose countersunk 3 dia and 6 dia has countersunk or depth. I will use 28 and I will again in line with this symmetric plane. I will place it from here. He has mentioned it is 10 mm away, and see it in front view there. I think that depth is not enough. More you can reduce the edit this whole 22 is enough, I think. Okay, now you can see, check this oil hole. Okay, now it looks fine. Some dress up features are required to finish this model. Here radius is mentioned as 10. Wherever it is mentioned you give otherwise 1 or 2 mm in order to avoid the sharp edges. Here he has mentioned inside view, he has mentioned R3. You can go for here also. You can avoid the sharp edges by giving 1 or 2 mm to avoid this stress concentrations. These corners have to be rounded off. Generally, if it is a steel part or iron part in industries, minimum of 3 mm radius is mentioned. Okay, I think this all the operations are finished. I think if you look any some more operations we have left, we have to look into the drawings. Something we have left over, even a small hole missing a small hole will lead to very confusion and problems in while doing the assembly. So look for the more details. I think this is enough for this part, and some radius here we have missed it, that we have to give here. Here mentioned 13 mm radius. Here also you give some 5 mm radius. Okay, I think we have done with this part. So the movable this body of the vice is ready now, and you saw it. It requires it consists of a lot of operations here. Still, you can minimize, but wherever holes are necessary, you have to give it. Yeah, this fillet and all within one operation you can give. I could not able to uh, give it in one shot, but you can minimize these fillets and holes. You cannot miss it, minimize it, and major operations wherever. The design process is a creative idea. One may, some other person may make it this part in an efficient way. So always it is iterative and feasible. We are tending towards feasible solutions. So um, even I have tried to minimize the operations. I think these are the minimum operations required for this to create this uh, part. So okay, immediately you hide all these reference planes and save it. Already this part is saved. Save, all the operations have been saved now. You just change the color of this. So just save this. Okay. Uh, I think for this session, I feel this is enough for this session. Uh, you take the drawing and in solid edge you try to create this model by seeing my videos, uh, commands what I have used for this, and simple profiles I created to remove the material to get this shape. Okay, so we will meet the in the next session to go further, attempt the further next parts. Okay, see you in the next session.